In this exercise, we're asked to find the limit as x approaches 2 from the left of the greatest integer of 2x divided by 2x plus the absolute value of x minus 2 divided by x minus 2. Let's take the limit of each one of these two terms separately. The first is the limit as x goes to 2 from the left of the greatest integer of 2x divided by 2x. Now, as x approaches 2 from the left, we know that the argument 2x will approach 4 but from the left. So it will be very, very close to 4, but it will not be 4. So this is a number somewhere close to 4 from the left. And since this is not an integer, we will pick up the very first integer to its left as the result for the greatest integer of 2x. So the numerator is going to go to 3. And the result of the denominator is just 2 times 2, which is equal to 4. Now for the other limit, let's look at what the sign of the argument of the absolute value of x minus 2. Now, as x goes to 2 from the left, now we know that x minus 2 will go to 0, but also from the left, which means that it will be a little bit less than 0, and it will bear a negative sign. In order to release the absolute value sign, we have to multiply the argument by minus sign. So this is equivalent to minus times x minus 2, because x minus 2 as x approaches 2 from the left will be negative, and this is divided by, of course, x minus 2. Now I can delete x minus 2 with x minus 2 because x is not exactly 2. So this is the limit of minus 1, which is equal to minus 1, and therefore this limit, the required limit, is equal to 3 over 4 minus 1, which is minus 1 over 4. Okay, this is a very similar exercise to the previous one, in which we're asked to find the limit as x approaches 0 from the left of the absolute value of x plus the greatest integer of x divided by x. Now, as x goes to 0 from the left, we know that the number is somewhere close to 0, but it is a little bit less than that. Since it is not an integer, then the greatest integer of x will be exactly equal to minus 1. Now if you look at the limit here, the limit as x goes to 0 from the left of the absolute value of x plus the greatest integer of x divided by x, this is going to be equal to the absolute value of x as x goes to 0 will be 0, of course, and the greatest integer of x is going to go to minus 1, and this is divided by 0 from the left side, which means it will be 0 with a very small number close to 0, but with a negative sign. So the numerator has a minus sign, the denominator has a minus sign, so the sign is going to be positive. And then now 1 divided by 0 is infinity. So this is the limit is plus infinity. Now it is also interesting to observe that the limit as x goes to 0 from the right, which is not required in this exercise, of the absolute value of x plus the greatest integer of x divided by x. Now look at the value of x, which will be very close to 0, but from the right here. So this is between 0 and 1, and we will pick up the very first integer to the left, which is 0. So the greatest integer will be equal to 0, and therefore this is the limit as x goes to 0 from the right, and this is the absolute value of x plus 0 divided by x, and this is equal to the limit as x goes to 0 from the right, and since we're going to 0 from the right, then the absolute value of x will be just simply x, and this is x divided by x, and this will be the limit of 1, which is equal to 1. If a graph is of interest to you, then this is a graph of the function of the absolute value of x plus the greatest integer of x divided by x. As you can see that if you approach 0 from the left, the function is going to go to plus infinity. As you approach 0 from the right, the function will sustain a value of 1. Okay, here's another exercise that involves the absolute value and the greatest integer functions. And we will look at this limit from both sides, as x goes to minus 1 from the right and as x goes to minus 1 from the left. We will also look at the two expressions separately. So the first expression, the limit as x goes to minus 1 from the right of the absolute value of x plus 1 divided by x plus 1. Let's look at the numbers that we are trying to approach. This is minus 1, and this is 0. And this is 1. So you're going to minus 1 from the right, so you're looking at numbers very close to minus 1 from this side, numbers such as minus 0.999, and now x plus 1 is going to be positive. with such numbers, and therefore we don't need the absolute value. So this is going to be the limit of x plus 1 divided by x plus 1 as x goes to minus 1 from the right, and x plus 1 can cancel with x plus 1, and the result is just 1. Now, if you look at the absolute, the greatest integer of x plus 1 over 2, for numbers such as minus 0.9999 plus 1, that is going to be 0 positive. So x plus 1 will go to a 0 positive. And if you divide that by 2, divide this by 2, so that will still be 0 positive. And therefore, 0 positive means that if this is 1, this is 0, this is minus 1. We're looking at numbers here very close to 0, but from this side, and the greatest integer of that number, which is not an integer, will be the very first integer to its left, which means it is equal to 0, and therefore this is going to be equal to 0. And therefore the whole expression is going to be equal to 1 minus 2 multiplied by 0, and the answer to that is just 1. Now let's look at the other limit, which means that as x goes to minus 1 from the left. Okay, so for the first expression, which is the limit as x goes to minus 1 from the left of the absolute value of x plus 1 divided by x plus 1, we're looking at numbers to the left of minus 1, such as minus 1.0001, and if you add 1 to that, that will be 0, very close to 0, but with a negative sign. Therefore, the absolute value of x plus 1 can be released if we multiply the argument inside by minus sign. So this is minus x plus 1 divided by x plus 1, and I can delete now x plus 1 with x plus 1, and the answer to that is equal to minus 1. Now for the greatest integer of x plus 1 over 2, now if you're talking about numbers such as minus 1.0001, and if you add 1 to it, that is going to, so x plus 1 is going to go to numbers 0 but with a negative sign, such as minus 0.0001, and if you divide that by 2, divide this by 2, this will still be a 0 with a negative sign, and therefore if you're talking about well, this is 0, this is minus 1, and this is 1, 0 with a negative sign, you're talking about numbers to the left of 0 here, and since this is not an integer, we will pick up the very first integer to the left, and therefore the answer to that is just minus 1. And therefore the limit now as x goes to minus 1 from the left will be equal to minus 1 minus 2 multiplied by minus 1, which is minus 1 plus 2, which is equal to minus 1. As you can see, the limit is plus 1. As you can see that the limit from the left is equal to the limit from the right, and therefore the limit exists and is equal to 1. In this exercise, I will show you that the correct answer is D. And I will also show you that B is incorrect, leaving all the other choices for you to investigate. So I will start by showing that B is incorrect. To do that, I will look at the limit as x goes to 4 from the right and also from the left. As x goes to 4 from the right, let's look at the numbers that we're dealing with. So this is 3, this is 4, and this is 5. If you look at numbers that will approach 4 from the right, so we're talking about numbers such as 4.0001, for example, and if you take the square root of that, the square root of numbers such as 4.0001 will be certainly greater than 2, because the square root of 4 is exactly 2, so this is a number that is greater than 2. So let me just write it as 2 plus. Now if you want to take the greatest integer of 2 plus, since this is not an integer and it is a little bit more than 2, so this is 1, 2, and this is a 3, so we're talking about numbers such as 2.0001, for example. It is not an integer, so I will pick up the very first integer to its left, and the answer is going to be 2. So now this limit is going to be equal to 4, since x is going to 4, and the greatest integer of the square root of x is going to 2, so this is 4 multiplied by 2, and the answer to that is just 8. Now if x goes to 4 from the left, this means now this is 4, this is a 3, and we go into 4 from the left, so we're talking about numbers such as 3.9999. If we take the square root of that, 3.9999, this is certainly going to be less than 2, because the square root of 4 is exactly 2, and let me write it as just 2 negative. Alright, so what is the greatest integer of that? We're talking about numbers such as this number that is very close to 2, but from this side. Since this is not an integer, okay, so we will pick up the very first integer to its left, which is equal to 1, and therefore this limit is x is going to 4, and the greatest integer of the square root of x will go to 1, and the answer to that is just 4. You can see that the limit from the right is not equal to the limit from the left, and therefore the limit as x goes to 4 does not exist, and B is incorrect. Okay, now let's look at the limit as x goes to 3, the limit as x goes to 3 from the right of x multiplied by the greatest integer of the square root of x. Now let's see what kind of numbers we're trying to approach. So this is 3, this is 2, and this is 4. If you approach 3 from the right, so we're talking about numbers such as well, 3.0001 for example, and if you take the square root of that 3.001, this is going to be approximately very close to 1.7. Now whether it's 1.7 or 1.71 or 1.69, it doesn't really matter, because what I will do is that I will take the greatest integer of that number, and that number of course is not an integer, so I will pick up the very first integer to its left. Now this is 1.7, which is equal to 1, and therefore this limit is going to be equal to 3 multiplied by 1, and the answer to that is equal to 3. Now if you investigate the limit as x goes to 3 from the left of x multiplied by the greatest integer of the square root of x, so let's look at the numbers we are trying to approach. This is 3 and this is 4, this is 2. You come into 3 from this side, which means that you are talking about numbers such as 2.999. If you take the square root of that, that is going to be also very close to 1.7. Again, if it is 1.6 or 1.78 or 1.71, it doesn't really matter. It's just an integer that is very far. It's not an integer that is very far from the two bounding integers. So this is between 1 and 2. It's somewhere there. Alright, and we will pick up the very first integer to its left, and the answer to that will be 1. So this is going to be equal to, as x approaches 3, this is 3, and that is going to be 1, and the answer to that is 3, and so therefore the limit from the left is equal to the limit from the right, and the limit is equal to 3 in this case, and therefore D is the correct answer.